In this video, we're going to review how to dilate segments that go through certain points. It's a little bit different than when you're dilating, I guess, figures or things like that, because you can tell that a figure has actually grown in size or shrunk, but lines end up looking the same. So we're going to do this example together. It says dilate the segment that goes through points 2, 2 and 4, 5 with a scale factor of 3 and then also a center of dilation of 0, 3. So I'm going to go ahead and plot the original points, 2, 2 and 1, 2, 3, 4, 5. Just for ease of us talking about the points later, I'm going to label them points A and B. You can do that too when you're doing these types of problems. It tells you want a scale factor of 3, but the next thing I need to plot is my center of dilation. Please note that this is not at 0, 0. It's at 0, 3, which is a y-intercept. So that's my center of dilation. That's really important to note that your center of dilation is over here. A lot of people tend to try to count from 0, 0, but you have to make sure you're counting from the center of dilation given to you. So next thing that we have to deal with is scale factor of 3. What you'll do first is you will figure out how to get from your center of dilation to one of the points. I'm going to choose to point A first. I'll write a note, 2A. From the center of dilation, which is 0, 3, I have to go down 1, and it looks like I have to go to the right 2. So I'm going to write that down, 1, right 2. Now, since my scale factor is 3, to get my new dilated point, so I'm going to call it A prime just to make it easier for us to refer to it, you're going to take all these and actually go triple that much because that's the scale factor. So instead of going down 1, I'm going to go down 3 times as much, and instead of going right 2, I'm going to go to the right 3 times as much as 2, which is 6. So from my center of dilation, I'm going to go ahead and do that. I'm going to go down 3 and to the right 2. So I'm going to draw out down 1, 2, 3, and to the right 1, 2, 3, 4, 5, 6. So this is my A prime, and we'll do the same thing for B. So to get to point B, the original one, from my center of dilation again, I have to go up, let's see, 1, 2, and to the right, 1, 2, 3, 4, to get to point B. So I'll say up, 2, and to the right, 4. So in order to get to B prime, the dilated point, I have to triple all of those. So I'm going to triple the 2, which is 6, and I'm going to triple the 4, which is 12. From my center of dilation, I'm going to go ahead and count up 1, 2, 3, 4, 5, 6, and to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Here's my B prime. So if it asks you to dilate the segment, then my new segment is going to connect A to B. Sorry, I didn't connect original A to B, so I'm going to do that too. Just so you know what the original segment looks like. And then this is my A prime to B prime. So that's first part. Second part is then to extend your segment and write the equation of the line that is your dilated line. So I'm actually going to make this line a little bit longer so it actually goes through. Sorry, that was not what I wanted originally. So I'm going to make this go past it a little bit. Now, if you don't make it so that your line is extremely accurate with a straight edge, it'll be a little bit difficult later on for you to be accurate with your equation, which is the second part we're going to go through. So I want to make sure that you're really careful about actually calculating this correctly. So if we are going to find the equation, we need to find out what the coordinates of the 2 points that we actually have are. So the 2 points, if I actually count, looks like A is at 1, 2, 3, 4, 5, 6, 0. I'm sorry, A prime, I should say. B prime, 7, 8, 9, 10, 11, 12. So it looks like 12, if I count, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can do this the traditional way. You can do like, oh, how much do I have to rise? How much do I have to run? But usually I also like to use like the slope formula. So I'll say 9 minus 0 over 12 minus 6. This is a sure shot way to also get your slope, but not the only way. Looks like I'll get 9 over 6, and I'll reduce that to be 3 over 2. So in my equation, if I use slope-intercept form, y equals mx plus b, I know for sure that the 3 halves will go in place for the m because that's my slope. So all I have left to do is find the y-intercept. For my line, I'm not really sure where it intersects the y-axis, so to be 100% accurate, I'm actually going to substitute a point in there instead of just guessing where this y-intercept is. So I'm going to just take one of the points, either 6, 0 or 12, 9, one of the ones that go through the line that you're trying to find the equation for. Let's use, I don't know, 6, 0 maybe. So I'll substitute in 6 for my x, and y is 0. So I'll say 0 equals 3 halves times 6, and then plus b. If I multiply 3 halves and 6, that will give me 18 divided by 2, aka 9, and subtract 9 on both sides. So it looks like my y-intercept is negative 9. Looks like my diagram was pretty close, but it wasn't 100% accurate, so that's why I wanted to calculate it instead of just guess by looking at my graph. And so in the end, if I look at my equation, I'll substitute in my y-intercept now, and now I have y equals 3x, or 3 halves x minus 9.